There's more than one way to build muscle. That is the good news. Now, it all stems from resistance training to a certain degree, but most of us are familiar with the good old myofibrillar growth. This is where you break down a muscle fiber and you tear it down and then it rebuilds stronger. And that really is the classical way. Now, there's multiple ways to achieve that, and we'll talk about that, but we're also going to talk about some other interesting pathways in which you build muscle through your training. So it's pretty interesting. This is going to be a two-part series. This first part, we're going to cover 6 ways that you build muscle, somewhat even unconventional ways. And then in the next part of this series, that's going to release tomorrow, and we'll link to it in the description, that's going to be a video talking about why you're not building muscle, how to kind of overcome some of these hurdles. So it'll be a great little series. So we'll just jump right into this first one. The first way that we build muscle is the way that most of us know. It's the way that a lot of the evidence is really rooted in. It's the classical hypertrophy model. It's where you are breaking down the muscle fiber and you're rebuilding it, possibly with more fiber number, but essentially with more fiber growth as the main part. But let's look at a study that was published in Frontiers of Physiology, because this breaks this down a little bit more. It helps us understand what we're after. So what this study did is it had subjects do 3 times per week of either high volume resistance training or high load, like a high weight resistance training for 6 weeks. And they looked at muscle cross-sectional area, all these different things. And what they found at the end of this design was that the people that did the high volume work actually had more muscle cross-sectional area than the people that did the high load work. Meaning it was actually more about volume for this myofibrillar growth, which is kind of interesting because when we look at it, we think, okay, we tear down a muscle. So the heavier the load, the more muscle we tear. But it almost seems as though higher volume with a moderate load was better. So it's not just about tearing it down. There's obviously other components here if volume is at play. More volume, more numbers of sets, more, not necessarily numbers of reps, but total volume will increase the total amount of load over a whole workout, right? So you could do slightly less weights and do more volume and actually get more myofibrillar growth. But how does this translate into protein synthesis? Well, the higher volume group also had higher protein synthesis. So we know that from a muscle protein synthesis side, it's pretty darn awesome to do a little bit more volume. But what does that mean? That's kind of loose. Like, how does this help us build muscle? What's the takeaway here? Well, with that, we look at a 2020 study, and this was a large review that looked at 28 different studies, and it helped us understand a little bit more of where we need to be. What this study found is that muscle strength gains are the most superior marker for muscle growth. Now, the nice thing about this is relative. It doesn't mean that you need to be bench pressing 1,000 pounds. It doesn't mean you need to be squatting 1,500 pounds. It doesn't mean that. It's a relative thing. So what they found is that moderate to heavy strength gains were superior to lightweight strength gains, meaning improving your strength is number one priority. But if you are improving your strength at a moderate load or a high load, you are going to have better improvement than just improving strength under a light load. But at the end of the day, improving strength in general is the highest marker, the highest notation we can make in terms of how you're building muscle or successfully building muscle. So what this tells us is that proximity to failure for myofibrillar growth and myofibrillar hypertrophy, this whole process, is the most important. Now, if you're doing light load, you're probably not going to get as much. But if you're doing a moderate load with higher volume, it's allowing you to get more tearing down, more breakdown for the average person. Now, a power lifter, it might be easier for them to just go and get their load in and get their total volume in by going heavy. But that's not realistic for most people that are trying to build muscle, maybe at the beginning or an intermediate level. So ultimately, the key takeaway here is proximity to failure, somewhat load dependent, is probably the biggest driver for mTOR. Total stimulation, anabolic signaling, and ultimately muscle protein synthesis. Now, as with anything that I'm talking about today, protein is going to be critical. Absolutely critical, because that's how you repair. That is your muscle protein synthesis, the other side of it, right? And it's also a stimulus in and of itself. So whey protein being highly insulinogenic, high leucine, so extremely anabolic, one of the most anabolic proteins you could consume. So yes, you want to load up on the whey protein. If you don't do that, yeah, you're still going to get possibly some growth if you get enough protein throughout the day. But realistically, it's best to just get a nice bolus of it in. I put a link down below for the whey protein that I use. It's one called Bowmar Nutrition, and it is Hands down, the best tasting whey protein that I have ever had. I mean that legitimately. 100% on my life, that stuff is amazing. If you make it with milk, it tastes like a literal milkshake, but it tastes super good with water too. So that's a 15% off discount link. Highly recommend you try their strawberry milkshake flavor. They've got their double chocolate. They've got all kinds of other flavors, and they're sweetened with allulose. So they're moving away from artificial sweeteners. I've been working with them to make sure that they're really using ingredients that my audience would like, because we have a lot of partnership opportunities on my channel with them, and it makes sense that they would align with the kind of things that I recommend. So we're working side by side with that, which is awesome. So that link is down below. They're sponsoring this series. So big thank you to them for allowing us to do this research and to really plug away and look into the details and giving us the opportunity to do that. So that link is down below. Definitely check them out. The next method of growth is a little bit different. It's sarcoplasmic expansion. Now, some people in the exercise physiology community would say, well, this is temporary muscle growth. It kind of is, but it can translate into more permanent growth. Now, sarcoplasms are those are the actual contractile proteins in the muscle, but these things can grow. They can expand. They can hold water. They can hold more glycogen. Okay, so when this ultimately happens, we have a somewhat temporary growth that translates. But check out the research and sort of the mechanisms, because it'll help us make sense. It'll help it make sense so that we can know how do we layer our training, so to speak. So there was a study published in PLOS 1 that took a look at previously trained participants, so people that have trained before. So it took these previously trained people and they took muscle biopsies before and after 3 and 6 week training loads. So they put them through different training blocks with lower volume and higher volume. Now their workouts were kind of interesting. Now this was a cool study because what they ended up doing is at the end, they took the people that had the most muscle growth and they did further chemical testing on their muscle to see other things that have happened. So they're like, okay, who grew the most? And of those people that grew the most, what was happening in their body? What's going on? So the workouts were kind of cool. Like day 1, it was like back squats, bench press, there was a lat pull down, there was a straight leg deadlift. Day 2 was very similar, except they added in a military press, like an overhead press. But the people that did the 3-day-a-week training program, they ended up having significantly more volume. So instead of doing 10 sets per week per body part or exercise, they actually did 32. So a huge jump in volume. So they wanted to see what happens when you have a big increase in volume. Okay, and those people obviously had more growth. There was significantly more volume, no surprise there. But here's what they found. There was a 23% increase in muscle cross-sectional area in that group. We're talking a significant amount more growth. So by going from essentially 10 sets to 32 sets per exercise per week, that gave them almost a quarter more gains. Okay, now, before I get into the sarcoplasmic side, let me just explain what this could look like for you. You don't have to do this all the time. This was progressively increasing to this. So they weren't doing this from the get-go. So what's cool is that you could occasionally load on volume and get significant growth out of it. You don't have to do high volume all the time. Even Dr. Mike Israetel talks about this. Like you could go do a volume spurt where you just be like, I'm gonna go high volume for a couple week period of time. And you get some serious growth that comes as a result of it. Now, some of that growth can be just sarcoplasmic growth. So let's talk about what that looks like. In addition to this 23% increase in muscle cross-sectional area, they found that a lot of that was an increase in sarcoplasmic protein concentrations, which means that there was just overall more intracellular water, there was more concentration of the actual proteins itself, and there was just an increase in glycogen. So carbohydrates actually stored more in there. And this whole thing persisted for about 8 days. So they had this growth, this sort of residual pump and growth that lasted for 8 days. But as a result of this, there's more blood flow, there was more fluid, and actually potentially more growth and intracellular volume that allowed them to get stronger with that internal leverage that they got. So even though this increase in size was like 8 days long, if you occasionally do these spurts of high volume training, you get growth through a different way. So again, to bring it back to earth, like you could do like your standard model of training with whatever volume you usually do and do a 2-week sprint of high volume, not just for mechanical and myofibrillar growth like we talked about first, but this temporary growth that you might see that's really kind of cool. there's a really interesting thing that happens within the muscle. It's called glycogen supercompensation. So when you have an acute increase in volume, the body actually says, wait a minute, is this guy going to start training a whole lot more? Let's start soaking up more carbohydrates into the muscle just to prepare. So it's a super compensation effect, which is great because A, allows you to eat more carbohydrates, but B, those carbohydrates go into the muscle. So you get fuller and you don't just get a better pump right after your workout, you're walking around for a period of time. Higher volume is gonna actually allow you to hold this pump that is more than just a pump at this point. It's actual sarcoplasmic growth and concentration increase. It's legit, even though some of it is fluid. You also have an increase in these sarcoplasmic enzymes because you have such an increase in ATP turnover. So you're creating and using so much more energy with this acute increase in volume that you actually have more sarcoplasmic enzymes. So now you have the ability to build more muscle and to get stronger. So occasionally going high volume for this sarcoplasmic growth could be really beneficial. But again, do not go high volume all the time. Do these spurts of it. And then of course the pump itself, like you have an increase in integrins, you have an increase in what's called MAPK signaling. All these things actually trigger growth. It's like there's these little anchors that are on our muscles, and when they get stretched with a pump, they sort of signal. They signal a number of things. FAK, they signal MAPK, these enzymes that we don't need to talk about right now, but basically the stretching and the growth of the muscle can signal this overall, or stretching and just kind of temporary growth can signal a more permanent growth later on. Now let's move into this third category, which is a very interesting one. This is the metabolic stress piece. It's kind of funny because when you look at all these different things within the body, even the brain, you have scientists that'll talk about all these different theories, and then all of a sudden you have a new scientist that comes in with a metabolic theory. There is a metabolic theory of why muscle grows too, and it probably coincides with a lot of these other things. No one is saying that mechanical growth isn't the main thing, but we are saying there's other ways too. So metabolic growth and metabolic stress, so to speak, is where you have metabolites that pool up. So when you train, you know you feel that burn, right? Okay, so you get a buildup of hydrogen ions, you get lactate into a dissociated form of lactic acid, and then you end up with inorganic phosphates. So you end up with these metabolic waste products that aren't really waste at all. They build up and they actually trigger some signals from a metabolic and cellular signaling side to induce growth. As a matter of fact, there was a study in Sports Orthopedics and Traumatology that was just published in March of 2025 that looked at this and found there is something there. It was a large review that looked at the metabolic sort of theory of building muscle. And here's what it kind of lays out. Metabolic stress can be an anabolic signal, straightforward. Okay, it's mainly the buildup of inorganic phosphate. So when the inorganic phosphate builds up, that's kind of what causes that peripheral fatigue, right? The burn and the overall fatigue. That is inorganic phosphate building up, causing a problem. This peripheral fatigue acts as a driver for more recruitment of muscle fibers and ultimately more growth. So this fatigue and overcoming the fatigue and overcoming the burn actually causes the recruitment saying, uh-oh, we need more. We need more help. We're fatiguing. We need it. Bring in the help as much as we can. This does amazing things. This allows for more growth. It allows for more fiber recruitment. So just by overcoming the fatigue, we go through a lot of beneficial things. Now again, there's the lactate accumulation. Lactate is not just what makes us burn. That's not even really the main thing. It's the hydrogen ions, the inorganic phosphate that kind of makes the burn and the fatigue. So when the lactate builds as a result of these things, lactate is this metabolic waste product that also acts as a fuel, but it is one of the primary signaling devices. What that means is it signals to the body to release other things like VEGF, vascular endothelial growth factor. This causes the growth of new capillaries and blood vessels, getting more blood flow to the muscle, more blood flow to the nooks and crannies to allow for actual protein synthesis to occur. Subsequently, you find an increase in IGF, insulin-like growth factor. Okay, this is another very important attribute when it comes down to the entire cascade of mTOR and muscle protein synthesis. So now we have the mechanical breakdown side, we have the sarcoplasmic growth, we have the metabolic side that is signaling, which probably works close in tune with the brain and with our metabolism and what we eat, right? So this mechanical signaling, so how do we capitalize on this? This is where really chasing the burn can help. So now the burn could be higher rep. It kind of coincides with the pump too, right? So the burn is going to be like, okay, trading in that mid-range, that 10 to 15 range, it just really burns, but going pretty quick rests between sets. Okay, not doing it all the time. But remember, how would we want to layer our training? Periods of mechanical growth, periods of high volume, as we talked about in the second segment, and now periods of short rest to really get a pump. Or BFR if you're into that, blood flow restriction training, save that for another video. But realistically, you're trying to just kind of load these metabolites up as much as you can. Okay, so things like 21s with bicep curls are such a good example, where you're doing full range, bottom range, top range, you're just burning. And that's a huge metabolic signal, right? So if you go short rest periods, you're never getting a chance to really clear that waste out, and you allow a chance to kind of build it up and trap it to a certain degree. So doing things like that, or going leg extensions and then going right into squats and just chasing a burn. You don't have to do this all the time, but we're layering these things, accessing these multiple avenues of growth. Okay, the next one I want to talk about is one that I know Dr. Mike Israetel talks about a lot, but that's the stretch-mediated hypertrophy. Now, stretch-mediated hypertrophy still kind of falls somewhat as a subcategory under the first thing we talked about. Okay, stretch-mediated hypertrophy is still sort of breaking down the muscle. It's where you're focusing more on the range in which you're loading versus just the load in general. So loading with a relatively lower weight and a stretched position, you're going to need less weight to overall load to the same degree, just because of simple like lever arm. There was a 2023 review published in Sports Medicine that looked at the stretch-mediated hypertrophy response, and it basically found that it's the same sort of mechanical growth that's occurring with mid-range, like normal lifting, right? It's just slightly different in the way that there's a little bit different signaling, but you're still tearing down muscle fibers in a very similar way. There's this thing that's called passive tension, and this is really focusing on those integrins. So those are those mechanical anchors. So I want you to think of like these mechanical anchors that sense load. Okay, so if you're just working in the regular range here, you're getting a certain degree of those suckers being activated. But once you stretch, these mechanical anchors, they are like sensors, and they're sensing the load through a different position. And this passive tension is causing mechanical stress, but it's also causing a little bit more of a signal from these integrins. As a result of this, you're going to send more blood flow there. You're going to send essentially more overall satellite cells, which are the cells that kind of fuse ultimately into the muscle to grow. They're like muscle stem cells. So this stretch-mediated hypertrophy, there's even some evidence that suggests that maybe there's a proprioceptive thing. Like by just going out into an extreme position, the body overcompensates in a way and starts to rebuild to kind of like protect, because you're saying, uh-oh, this person's going to get into a stretched position. You have to be really strong to hold a stretched position. You got to be really strong there. So maybe there's a compensatory mechanism where the body's saying, we need to strengthen this to make sure that we're not going to tear and rupture when this guy does this, right? So thinking about that, how do you apply this? This is where I might recommend like looking at some of Dr. Mike Israetel's work with this, because he's done a lot of this, and I don't want to speak out of turn. But the reality is that occasionally doing these extreme stretch movements or doing these movements where you're really getting into a stretched position, maybe a couple exercises out of your day, you're activating these different mechanisms. But I think the thing that I take away from this as someone that's a busy person with young kids and I don't always have time to do high volume work is maybe I don't have time, or I'm too lethargic that day to really go balls to the wall with my training. Maybe I could do some lower intensity stretch mediated work where I'm really working the stretch with a lighter weight and lower volume that day, and know that maybe I'm not just preserving muscle, but I might even be growing muscle via a different pathway that day. So accessing these different pathways are really, really, really important, because this is how we get the most out of it. Like we can access these different pathways if we're not in the mood to just go back squat 500 pounds. Now I'm going to focus on a couple honorable mentions here. First one I want to focus on is a highly scrutinized thing known as time under tension. Now, the thing is that time under tension isn't a unique mechanism to build muscle. It's just capitalizing on a lot of the different things that we talked about. So people like to train where instead of focusing on the load, they're focusing on how long is my muscle under tension. I would like to rephrase this a little bit more as maybe just eccentric focus training, where you're doing more like eccentric movements, which is really going to capitalize on that classical model of myofibrillar growth. You're just tearing, because anytime the load is overcoming you, you're tearing down more. But we've seen in a lot of work that eccentric might not be the best for hypertrophy. It might be good for stability and some other things. I'm not an expert right there. But the point is that, yeah, some time under tension work could be good. Now, there's these things that are called focal adhesion sites, and these work really closely with those integrins I talked about, those mechanical anchors. So when you have the weight overcome you, okay, those integrins that are sensing the stretch and sensing the load, those obviously can do some work themselves, but then they have these things called focal adhesion sites, and when you kind of bust through and you let the weight overcome you, those focal adhesion sites somewhat get activated. And when they get activated, it signals chemical changes and it signals mechanical changes that allow you to build muscle. So then you're recruiting other molecules, then you're getting a metabolic signaling. So the thing about time under tension is it is kind of combining a few different things. It's combining the metabolic piece, because you get a lot of burn when you're doing time under tension or you're doing eccentric loading. So I'm not here to necessarily advocate for time under tension as a method. I'm here to say the eccentric loading piece might allow you to get a little bit of all of these things that I've talked about, but I don't think that the science is quite there to say this is really the solid way to go. I will honestly say that I had a lot of success with it because there was a period of time where I had so many injuries I couldn't really lift heavy. So it's an important one to at least mention. Another one that's very important to mention, and I don't think has enough science on it just yet to really get crazy excited, but I am cautiously optimistic, and I could even say bullish, on isometric training. Okay, some of the most esteemed academic people that I know and people that are really in amazing shape do serious isometric training. So I don't really understand the mechanisms of how isometric training could be working outside of the nervous system. The nervous system, like you're kind of forced to tax the CNS in certain ways that it's usually not used to being taxed. You're holding in a static position. But there's also really good anti-sarcopenia, like that's muscle wasting and kind of the degradation of muscle as we get older. So these mechanisms where people will just do isometrics and actually preserve muscle. So there's something there. And I'm inclined to think that it has more to do with nervous system and possibly even proprioception and some of just how our pain tolerance can contribute to muscle growth. That's really early stuff, and I don't want to speak out of turn, but the point is that perhaps dealing with pain in a constructive way could allow us to bust through these barriers. That's why progressive overload and proximity to failure works. It's like muscle growth is rewarded to the person that can endure pain and get their brain right to endure that pain. Isometrics, there's no better way to endure pain. If you've never experienced true pain working out, try doing isometrics. It's a relatively safe way to induce that pain. So I think it might also train you to feel safer in certain positions. So if you were to do an isometric contraction in a wall sit at a low level or low squat, maybe it's going to train you to kind of get the nervous system to turn those muscles on a little bit more. Again, I'm not an expert there, but I've seen it firsthand. So now we've talked about these 6 different ways of building muscle, really the 3 pathways, right? The mechanical breakdown, the sarcoplasmic, which I'm most excited about, and the metabolic. So how do we all layer these? Remember, okay, we're gonna do occasional classical breakdown, or fundamentally classical breakdown with our typical hypertrophy training, 2-week volume sprints, so we get that glycogen supercompensation and we get all that. Then we're gonna do periods of time after that where we go maybe a week or so of really fast metabolic training where we're not doing cardio in between sets, but we're moving quickly between sets. We're not focusing on the proximity to failure so much as we are focusing on the burn, right? That's what we're really after with those. And then we're occasionally adding in the stretch-mediated hypertrophy in our given workouts, doing 1 or 2 exercises where we're really focusing on stretch and getting that out there as much as we can to get that induced response. Now, I'll see you in the next episode where we talk a little bit more about some of the mistakes, but also why you're not building muscle independent of just these pathways. See you tomorrow.